So, welcome learners. Welcome to you all beginners. So, let me introduce myself to you. I'm called Charles Isapo. I am an electrician like you, like what most of you want to become. I've been working in this field for more than 20 years now, and I thought it useful to share my little experience with the beginners especially. So this course, as you can see, the course title is Introduction to Electricity for Beginners. But why do we talk about electricity? Well, everything we do is electricity involved in it. In our homes, in our cars, in our phones, whatever we use, it is directly or even indirectly connected to electricity. And I want to believe that most of you new ones, learners, beginners, are very much interested to know how to go about this beautiful current that we use in our homes and anywhere. So the course of this has objective. This course has objectives. The objective of the course, we have about 6 of them, or not to say 5. By the end of the course we are now starting, you learners or you beginners need to be able to first of all understand what electricity is and how it works. The second point that is as an objective in this course is to identify the key electrical quantities, which are the voltage, the current, the resistance, and the power. Number 3 point, which stands as an objective also, is to understand and apply Ohm's law. The Ohm's law is the fundamental law for electricity, without which nothing can work, can go. The fourth point that is an objective in this course is to recognize common electrical components and their functions. When we talk of components, we have in mind, for example, switches, sockets, bulbs, breakers, and all their functions also. And the last point, which is not the least, is to be able to read and interpret simple electrical circuit. For example, if somebody just sent a circuit to you with a component, you should be able to read to know where the socket is, where the switch is, where the bulbs is, where the panel is, and so forth. So these are the objectives of this course. Can you remember them? There are 5 of them that we mentioned. We'll be coming back to this objective if the needs be. Now, to start, let's try to define what electricity is. If someone asks you, if somebody sees you with a screwdriver, with a plier, with a tester, or with a multimeter, and if person approaches you and then asks you, what is electricity? What will you say? Well, electricity is simply defined as the flow of electric charge. The flow of electric charge, typically through a conductor such as a wire. So as you see a wire, there is an electric charge that flows through from one point to another, and that's why we call electricity. So this flow, the flow of the charge, of the electric charge, is called an electric current. The flow of the electric charge through a conductor such as a wire, as you used to connect wire from point A to point B. This flow is called an electric current. So remember, electricity is the flow of electric charge from point 1 to point A, or rather from point A to point B, and the flow is called an electric current. Now, in this electric current, there are some elements or components that are involved that it will be good to know. We have such of those ones that we call atoms and charges. Atoms and charges. For example, a matter, when we talk about matter, hope you understand, a matter is made up or is made of atoms. Atoms. Now, these atoms that makes up a matter contains protons, which are symbolized in bracket by plus, neutrons was symbolized in parentheses by 0, and electrons, which in parentheses are symbolized by minus. The atoms contains protons plus, neutrons 0, and electrons minus. So electricity now involves the movement of electrons from one atom to another. The movement. It can be a circle, it can be a length. That's electricity. But you may wonder, we've been talking about electricity. Are there some categories or types of electricity? The answer is yes. The answer is yes. We have two types of electricity, two of them. So the first type is a static electricity. When we talk of something static, as we know, is something that is not mobile, So we have a static electricity. It's built up of charge on the surface. The charges are on the surface. It's like when you are rubbing a balloon. When you are rubbing a balloon, just charging the balloon on the surface. So this is what we call static electricity. The number 2 is what we call current electricity, which is commonly used in homes and any other places that you may imagine, bakeries and other places. And then this current electricity is a continuous flow of electrons through a conductor. That's, for example, when you want to connect a bulb to a switch, there is a cable that goes from the switch to the bulb. This is the current electricity. Continuous flows of electrons through a conductor. That conductor takes it from the switch to the bulb. That's what we talk about current electricity. So still, we've been able to define electricity and some components or elements that are involved, like atoms. We mentioned electrons, we mentioned protons, and you can remember we equally mentioned neutrons, and we mentioned two types of electricity that we have. But in the course, we must be using current electricity. So are there some quantities that are important in our learning process as new learners, as beginners? The answer is obvious. For example, if somebody sent to you a document where you just write the quantities V, I, P, R, you should be able to read and interpret what this quantity stands for. So we have about, in our electrical quantities, we have four main electrical quantities that are like the base that ties the whole work of electricity that you will be doing. The first electrical quantity that we want to talk about is voltage, and then it is usually interpreted by letter V, the V letter. Now, what is voltage? At times you used to hear an electrician or a technician saying the voltage is very low. This bulb is not shining because the voltage is low. What is the voltage? Well, the electrical potential between 2 points is what we call voltage. What do we mean by electrical potential between, or electrical potential difference, rather? Electrical potential difference between 2 points is what we call voltage. But you may still ask me, why do you mean by electrical potential difference between 2 points? Well, to be practical, I would like you to imagine a bulb and a bulb holder. Usually, when you take a bulb holder, you have 2 points, 2 connection points there. You have 2 points where you have to connect. You have plus and you have minus. So those 2 points, plus and minus, those 2 points where 2 wires or 2 conductors have to enter live and neutral, as we call it in another language, is what we call the potential difference. Potential difference between the 2 points, because usually the difference between the 2 points for a bulb to light well should be 202 V. 220 V, sorry, 220 V. So when you have this 220 V, it means that the difference between the 2 points is correct. So that is what we call voltage. Now, we want to visualize it. We would think of it as the pressure that pushes the electrons. The pressure that pushes the electrons, if we want to think of it that way. Don't forget, we say electricity involves the movement of electrons. That's what we said. So the voltage, we think of it as the pressure pushing the electrons. We're still talking about electricity. It pushes the electrons. And the unit of the voltage is V, letter V, capital letter. The second electrical quantity we would like to talk about here is the current itself. You used to hear some children screaming sometimes in the quarter, they have cut the light, they have cut the current. What is it, current? Well, the definition we can give for this is current is the flow of electric charge. The flow of electric charge. That's how we can define current. And the unit for current is amps. A capital. If you want to write it all through, it is A-M-P-E-R-E-S. Amps. That's how it is. Now, if you want to think about it, you think of it as the number of electrons flowing per seconds. The number of electrons flowing per seconds. That's how you think about it. Don't forget, for voltage, we say it is the pressure pushing the electrons. But for current, we are talking about number of electrons flowing per seconds. That is current. The third element we want to mention, or the third electrical quantity to be specific, we'll be referring to is the resistance. The resistance is the opposition to the flow of current. You usually sometimes say, I'm going to resist this. Sometimes you are simply meaning you will oppose what the person is about to say or to do. So it is the opposition to the flow of currents. It's like if the current is flowing from point A to point B, the resistance will like be opposing the flow coming from point B to point A. That's resistance. And the unit of this quantity is ohms. Ohms. We'll talk more about it later. And then it will be good for you to also know that all materials resist the flow of current to some degree. All materials. There are some materials that resist current in a very high degree, but almost all resist to some degree. It depends on the material you are using. The fourth electrical quantity we want to mention is power. We commonly hear people say this guy is very powerful, is very strong. So when it comes to electricity, how do we define power? Well, it is the rate at which electrical energy is consumed or generated. You know, usually when the company in charge of distributing the bills, the electrical bills in our area, comes to you with your bill, you used to ask yourself, wow, I consumed too much this month. Wow, did you iron dresses much? Did you warm water? Did you use the electric cooker and so forth? So the rate at which electrical energy is consumed is called power. That's why it'd be good to know how to regulate the consumption. Yes. So the unit for this is watts. Watt, W-A-T-T-S. And the formula for you to calculate this is very, very important, because it is P equals to V. P stands for the power, equals to V, who stands for the voltage, times I, who stands for the intensity, or for current, I, who stands for current, and P, who stands for power. So when you overall calculations, you have equals to V times IP equals to voltage times current. It is usually, since voltage is V, current is I, power is P, you usually see power equal to voltage times I, who is current. So you see P equals to U, who is the unit, times I, who is the unit of current also. A very simple yet important formula that is to know. Another thing which is worth mentioning equally is the Ohm's law. In electricity, new learners, beginners, have to know the fundamental law of electricity. So the Ohm's law is the fundamental law of electricity without which one cannot really succeed in this field. So what's the formula? In this formula, we will be using the quantities that we mentioned earlier. Can you remember what V stands for? I stands for? R stands for? It would be good if you remember this, because the Ohm's law formula is V equals to I times RV. So it is I times RV, which is V equals to I times R. If you want to use it in terms of units, it will simply means U stands for IR. As you see, V stands for IR. Where V is voltage, I is current, R resistance. And remember, voltage is, the unit is V, current is I amps, and resistance is ohms. So a very simple example they can give you is for if a resistor has a resistance of 5 ohms, for example, and a current of 2 ohms flows through it. What is the Ohm's law for this? What tension or what voltage might you have on this? You simply do the calculation. You will see you have to take the resistance and the current of 2 amps, you multiply, which is going to easily give you 10 volts. So this is the Ohm's law. You should be able to calculate it. Simply put it is U equals to Ri, and then you can reverse it the way you want to reverse it. So a very fundamental law for electricity. You remember when we started this course, we made mention of components. Can you remember when we made mention of components? Yes. If you remember, good. If you don't remember, don't worry. We shall come back to that with times. So let's talk a little bit about some basic electrical components. These components are not exhaustives. So I simply mean this one are not all the components that are used in electricity. There are many other components that you will be able to know as we will be discussing or will be processing together. But the first component that we would like to learn here is the resistor. With time I will show you the symbol of a resistor. You remember about other quantities. When we talk of quantity, we mention resistance. Now we are talking about component. We are talking about resistor. So don't confuse. Don't get confused. Don't get confused. When we talk about electrical quantities, we talk about resistance, which opposes the flow. Here we are talking about a component, which is different from a quantity. That is a resistor. And then the resistor reduces the current's flow. It's, resistance opposes, resistor reduces. So get this in mind. Another electrical component that we know is a battery. Yeah, I know when I talk about battery, everyone knows the battery, because a car cannot move without a battery charge. And then we simply understand that the battery provides voltage to the circuit That's why sometimes when they want to start a car and it does not get started, you will see the person going to the battery and making sure it is well tied. A very common example we can use to help all of us understand the importance of a battery is in our phones. All of us own a phone, So when your battery is low, does that provide voltage to the circuit of the phone or the cellular phone? The answer is no. At times you want to receive a call or you want to launch a call, and then the battery becomes low. You become saddened. It is this battery that produces current or produces voltage to the circuit. So that's a component. The battery is a component, an electrical component. Keep this in mind. Another electrical component that most of us we are used to is a switch. We talk about switch. Before you enter your house, you on the light. It opens or closes a circuit. On and off. Turns it on or off. An electrical circuit. A switch turns it on and off. So this is an electrical component, a switch. Another electrical component that we have, that we always enjoy especially, is a bulb. The bulbs that we use, no matter the bulbs that you see, just know that this bulb converts electricity into light. It converts electricity into light. And another component that we have without which we cannot have light in our house is a wire, which conducts current between the components. For example, if you put a bulb here and you put a switch here, if there's no wire to connect these two components, it can't work. So it's good to know the quantities. You remember the quantities we mentioned earlier. And here we are talking about components. We mentioned resistor. You remember it reduces the flow. We said it. We mentioned the battery. You remember what we said that the battery does? We said the battery produces or provides voltage to the circuit. It provides voltage to the circuit because once it is charged, it provides. We mentioned a switch that turns on and off a circuit. We mentioned a bulb that converts electricity into light, and the wire conducts current between components. It conducts point A, point B, bulb, switch. That's what a wire does. At times, as you work, you may realize that one switch has to connect to 10 bulbs on the same line. And you may also notice sometimes that one switch still has to light 10 bulbs, different position, but not on the same line. It's like maybe a square or a triangle, or it depends. So we want to talk about circuits. All this either align or not align or done in a different way. This is an electrical circuit. When we talk of electrical circuit, we'll talk about two types of circuit. The first type of circuit we would like to talk about is what we call series circuit. This series circuit has one path for current. One path for current. So if you have, for example, 10 bulbs, the current is the same into all these 10 bulbs. This is a series circuit. If you have bulb 1 to bulb 10, a series circuit has, if the current in bulb 1 is 001 amps, don't forget amps is the unit. of current that we earlier set, the 10 bulb, you're going to have the same 001 current. So it is the current that goes through all those components. It's the same current that goes through. And when you want to calculate the resistance, it adds up. It's the same. This is a series. Now, a parallel circuit is quite different, just a bit. For the circuit which is parallel, we have multiple paths for current. The voltage is the same in all branches, and the resistance there decreases. So the difference in between these two circuits that you need to keep in mind is that for the series circuit, the current is one path, and the voltage is different path. For the parallel circuit, we have multiple paths for current, and the voltage is the same across the branches. The difference is a little bit the resistance. So the three values are different in the two types of circuit, and we should be able to distinguish this when it comes to calculate. Series circuit, one path for current. The current is same through all components. All the components we mentioned is the same current because it is a line. Parallel, the multiple paths for current, because you have current 1, current 2, current 3, for example. But as for series, you have current 1. And then voltage 1, 2, 3 for series. But for parallel, we have current 1, current 2, current 3. Voltage is just 1. Now, while the resistance adds up in the series, for the parallel circuit, the total resistance decreases. So it's good to know this as you want to embark in this beautiful learning of electricity, which brings light to the world. Now let's take a very practical example that we want to use. Imagine you take a battery of 12V, a battery of 12V to a resistor of 6 ohm. Remember that the battery and the resistor are all components, electrical components, as we mentioned. Now, what do you think is the current? The battery is 12V, the resistor is 6 ohms. What do you think is the current? Do you remember the fundamental law we can use to calculate? Remember, we said the fundamental Ohm's law is U equal to R times I. Remember. Okay? Now, if you take U or V equals to I times R. Now, if they ask you to calculate the I, which is the current, how will you go about it? You simply take I is going to stand for V divided by R. U equals to I times R. I is going to stand for U. I is going to be I equal to U divided by R. And this practical example, you remember that the V is 12 volt and the R is 6 volt. So you're going to divide for you to have the current, which is I, 12 divided by 6, which is going to give you 2 amps, which is going to be the current that it will flow. You see why we said earlier that the Ohm's law is the fundamental law for electricity, which you really need to keep in your mind and you'll be using from time to time. So some practical examples also that you need to keep in your mind, though you are learners, has to do with safety. Because you remember, as we are in our homes, you may travel somewhere and then someone's bulb may get bad, or something else may get bad, and then you may be called to come and change or do something, though you are a learner, a beginner. So keep in mind that in this life, in this work, in this our field, safety is very, very important. So we can't close this introductory lesson without talking about safety. So safety first. Keep it first. Safety. The first thing you need to keep in mind as comes safety in electricity is never touch live wires. You understand what we mean by live wires? Well, let's get back to what we said at the beginning. A live wire is what we call the potential difference between the 2 points. You know, we have 2 wires, the plus and the minus, to be very easy to understand me. The plus wire is what we call live wire, and the minus wire is what it's usually called the phase and the neutral. So the live wire is the phase and the other wire is neutral. So in as much as you don't have the tester to know which one is live and which is not, don't touch live wires. Don't touch. Never touch live wires. Another safety point you need to keep in mind is if you want to work, if about to do an electrical work, use insulated tools. For example, you may find it contradictory, but in the field, at times, the need might arise for you to touch these live wires. Yeah, the need may be there because maybe there's a problem. So if this is really the case, and as long as you are trained for this, use insulated gloves. That's what they say, use insulated tools. Because the safety says never, but at times the need may be there for you to do that. In that case, use insulated tools. So you want to use good judgment. Use good judgment, really, in this before you attempt to touch whatsoever. And also, make sure you turn off the power before working. What do we mean by turning off the power? Normally, you need to go to where the main breaker is, not the company that supplies the electricity breaker. Usually, there should be an electrical breaker inside the home or inside the house, and this electrical panel has a main breaker. So you have to go to this breaker or this switch, main switch. You put it off before you begin to work. You make sure it remains off before you begin to work. Also, as you be working, make sure you wear rubber gloves when needed. It's not advisable to work with naked hands, Always try to wear something that is going to protect you. So these are some precautions that you can take before you start working. So if you want to do like a small summary in this course, remember we started by talking about what electricity is. That's what we said from the very beginning. We define electricity, if you can remember. We define this as the flow of electric charge. Can you remember that that's how we define electricity? It is the flow of electric charge through a conductor such as a wire. And that's why we called it an electric current. This flow, as you see water flowing, that's how electricity flows through a wire. And we call this flow electric current. This is something you need to keep in mind. You also remember we mentioned two types of electricity: the static and the current electricity. We mentioned electrical quantities: voltage, current, resistance, and power. We discuss the fundamental law, which is the Ohm's law, which is the fundamental law in electricity without which what cannot really proceed, cannot do something very, very substantially important in this our field. After talking about the quantities and the Ohm's law, we talked about component. And we said this electrical component mentioned here for beginners are not all. There are many other components that we will come to discuss when we will continue this our course. And the components we mentioned today, we mentioned the resistor, we mentioned the battery, we mentioned a switch, we mentioned a lamp or a bulb, we mentioned a wire. We equally discussed something very important that it would be good for you to know. We talked about two types of circuit: a series circuit and a parallel circuit. We're able to know the difference between the series circuit. The current is the same, the voltage is different, which is the opposite for the parallel circuit. We have multiple paths for currents, but voltage is same for all the branches in the parallel circuit. And we talk about if the resistance adds up for the series circuit, it decreases for the parallel circuit. We took an example of a battery. We mentioned safety measures. We don't need to touch live wires. If it becomes necessary, urgent, we need to be trained and then use insulated tools. That we need to use insulated tools when we are working. Insulated screwdriver, insulated pliers, and then equally we can wear insulated gloves. We also say we need to turn off the power before we work. Yes, turn off the power before we work. We go to the breaker, we put it down, we off it, and we wear rubber gloves when needed. So as a summary, we want to talk about the quantity, the symbol units, and the instrument. Remember, when we talk about quantities, we mention four of these quantities. Yes, we talk about voltage, we talk about current, and we talk about resistance and power. Now, just imagine you want to know the voltage in the house, where you stay, where you live. You want to know the voltage. And then you want to be curious to know which instrument is needed for you to measure the voltage. Do you know the instrument? Well, there is this common instrument that we all know. If you want to know the voltage, you use the voltmeter. Do you know what the voltmeter is? We'll come to know about this. If you want to know current, which is symbolized by I, you know the ampere meter. That is the instrument that is used when you want to know the current. If you want to know the resistance, you use the ohm meter or the multimeter. And the power is usually calculated via V times I. So these are the instruments that I use. So dear beginners, dear learners, we want to thank you for your being there, present, watching, paying attention to this, our course. That is meant especially for beginners, for new learners. And then next time we're going to discuss something else, which is going to be as interesting as the one that we discussed today. Thank you so very much for being there. Thank you for listening. And then hope to see you next time.